the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is dedicated to linear algebra students and, again, pre-calculus students who are going through matrix algebra right now. This video is going to focus on the transpose of a matrix, which generally is not taught in pre-calculus and is focused on in linear algebra. I suppose you could teach it in pre-calculus, but I wouldn't know why. To be very honest with you, there's no need for it, at least in pre-calculus. So anyhow, what is the transpose? Well, given an M by N matrix A, the transpose, is the N by M matrix that we denote as A with a superscript of T for A transpose, whose columns are formed from the corresponding rows of A. Basically, you just swap rows and columns. The best way to see this is through examples, so let's go ahead and do some examples. Here's a simple and trivial example. We have a 2 by 2 matrix. Here we have column 1. We're going to make it row 1 in A transpose. And here's column 2. We're going to make it row 2 in A transpose. Very exciting, right? It's okay. By the way, you know how I read that? I read it backwards than what the definition states. The definition states the columns are formed from the corresponding rows of A. That is, this column is formed from the first row of A. This column is formed from the second row of A. Notice they are exactly the same. So as far as whether I started with columns and transposed them to rows or rows and transposed them to columns. I should go by the official definition though. So let's continue forward using the official definition. So here's a matrix B. It's a 2 by 3 matrix. B transpose, we're going to take row 1 and make it our first column in B transpose. Then we'll take row 2 and make it our second column, in B transpose. Notice B transpose is a 3 by 2 matrix. There's not a lot I need to say about that, right? It's pretty easy. Take row 1, make it column 1, take row 2, make it column 2, take row 10, make it column 10, that type of thing. This is not really fascinating yet, but there are some very important properties of the transpose that will be used in linear algebra. Speaking of properties that will be used in linear algebra, if we let A and B denote matrices whose sizes are appropriate for the following sums and products, the following must be true. A transpose transpose is equal to A. That is, swap rows and columns, and then swap columns back to rows, and you get to A. That should verbally make sense to you. The next one probably doesn't make sense at all. A plus B transpose is actually A transpose plus B transpose. That is an odd statement, but very, very true, and that's the one we're going to prove. Another one, for any scalar R, the transpose of the scalar times A is the same thing as the scalar times the transpose of A. That should actually make sense, because when you take a scalar and multiply it by a matrix, you're essentially just scaling up that matrix. And then when you rotate or flip rows for columns, you could still factor out that scalar multiple out of all those entries. So that should totally make sense. And finally, this is really one that makes people think, usually this is a homework problem to prove this. AB transpose is B transpose A transpose. That is going to be one that does come up quite often, or at least often enough to be annoying. So you do have to remember that. But let's go ahead and prove B right here to show you how a proof would work with transposes, how you would kind of approach these proofs. Since the transpose trades or swaps the roles of the rows and columns, the ijth entry of A plus B transpose, so I'm looking at, let's say, the third row, fifth column of A plus B transpose, that is born from the fifth row, third column of A plus B. In other words, the ijth entry of A plus B transpose is the jith entry of A plus B. And this entry is A sub ji plus B sub ji. Remember, the ijth entry of A plus B transpose is the jith entry of A plus B, and the jith entry of A plus B is A sub ji plus B sub ji. Therefore, the ijth entry of A plus B transpose is this. Now that's not the end of the proof, that's just the gateway to the proof. But we have now shown that when I'm looking at the ijth entry in A plus B transpose, I know what it is. It's A sub ji plus B sub ji. However, the ijth entry of A transpose likewise is the jith entry of A. And the same can be said for B transpose, by the way. When I say the same is true for B transpose, I mean the ijth element or entry of B transpose is the jith entry of B. Thus, the ijth entry of A transpose plus B transpose is A sub ji plus B sub ji, which is exactly the same as the ijth entry of A plus B transpose. Since those two entries are the same and I and j were arbitrary, that means that A plus B transpose must be the same as A transpose plus B transpose. And that is the proof of B right up here. Anyhow, that's all I really have for this video. So I hope it was helpful. I know that there tends to be a lot of frustration when people watch a proof. They're just like, what just happened? But you're watching it on YouTube. So what you can do is pause, rewind, take some notes, try to digest it, walk away, come back, scream at your screen, whatever you need to do. Anyhow, you could also ask questions in the comments. I actually do respond to them. So I hope you have a wonderful day, and I hope you'll be a wonderful human being.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.